Okay, this is 8-4, our age problems. So when we first read this equation, we find that we have two, I use the box to organize, and the first thing we're going to do is look at what are we comparing. And whatever items we're comparing, we're going to list them on the left. So we're comparing Jan and Barb. And then we're also comparing their age. And they talk about two different time periods. So the first thing we're comparing is their time now, their age now. And then we're going to look at their age in 4 years. So do we know their ages now? So we're going to just, if we don't know Jan's age, we're going to call her, how about X? We give a variable for an unknown. Now, what would her age be in 4 years if her age now is X? Yes?
X plus 4.
X plus 4. And do we know Barbara's age?
No.
So what are we going to call her? How perfect. Okay, we said that we're going to call Jan in 4 years, she'd be X plus 4. What will Barbara's age be in 4 years? Y plus 4. Now, I'm only using this box method to... The only reason I'm using this box method is to organize my information. So, now I'm ready to write my equation. And in this problem, it's actually given me something that looks like I can translate it. Jan, what do I put for Jan? And is 16 years older than, and notice it says older than Barbara, and they're saying now. 16 years older than, what do I write for older than? Yes. Plus 16. Notice I'm going to switch. My 16 goes to the right of the plus sign, and what goes to the left? Y plus 16. There's my first equation. Now, in 4 years, that means which time period am I using? The future one. I'm not going to use this. Instead, I'm using these terms. Right? So in 4 years, the sum of their ages will be 50. So how's that going to look? In 4 years, Ari.
X plus 4 plus Y plus 4 equals 50.
Good. Now, what's the easiest way to solve this? Easiest way. I have two equations. We have 3 methods. I don't want to graph this, do you? No. So then that leaves us with 2. Substitution and elimination. I want to hear from somebody else. What's the easiest way to graph this? Tomer. When do I use elimination?
You can get rid of.
No. Who remembers when we use elimination? Who remembers? Jessica.
Isn't it when they're all lined up? Like
In what kind of form?
Y standard form.
Standard form. Are these equations in standard form?
No.
So we're not going to be using elimination. So what's the easiest? Rihanna. Substitution. I can substitute this for my x. Okay? So there's an x there, and I'm going to substitute it. Y plus 16, right? That's for x. And then I'm writing everything else. Plus 4, plus y, plus 4 equals 50. And now I've got 2y plus 24 equals 50. Right? 2y plus, that's 20, plus 4. See how I just combined my like terms. Next step, subtracting 24. We're left with 2y equals 26. Divide by 2. And y equals 13. And then I go right up here to my box and I write it down. And now can I figure out what my x is?
Yes.
Okay, Jamie? How, how do I figure it out?
Oh, you would take 13 and then you would get 16 units because she's 16 years older.
Because I substitute 13 plus 16. And so x is equal to what? 29. And we are done with our first official age problem. Now, can we make sense of it? Sarah Kim, what does this mean? Now, make sure you're clarifying that because the question is, how old is each now? Jan's age now is 29 years and Barbara is now 13. Okay, questions? Yes.
Would it be in 4 years?
It says the sum in 4 years.
Oh, okay.
In 4 years, the sum of their age will be
So if
50.
you just add 4 to them, then it'll be...
4 and 4. 29, 13. X is 29. I'm using this.
Oh, yeah,
right here.
33. Okay, never mind.
29, 13, 4, and 4. Okay? When you add those up, that equals 50. Okay, questions? So, let's try this next one. You want to do it together?
Yeah.
Okay. Mary is 18 years older than Sarah. 5 years ago, Mary was twice as old as Sarah. How old is each now? Now, how am I going to label this right here? How am I going to label this right here? Who are we comparing? Somebody. Mary and Sarah. Only this time my time is broken up by what? 5 years ago and now. Because they say Mary is 18 years older than Sarah. That's the now. 5 years ago. So this box is going to be age now. And this box is going to be what? Yes.
X minus 5?
No. Yeah, it's going to be 5 years ago. So let's call Mary our X. And let's call Sarah our Y. Now, how am I going to call Mary's age 5 years ago?
X minus 5.
And what's Sarah's age 5 years ago?
Y minus 5.
Good. Now, the hardest part about these kind of problems with the box is that kids forget how to set this part up. So you should be really writing all of that. How to set the box up. They get the box and then they forget how to set it up. So make sure you're labeling all parts of the box. So now I'm going to do my translating. Do you guys want to try and do the translating alone?
Yes.
Okay, pause the video and try and translate as best you can. All right, now check your work for translating. How do I do Mary? Oh, shoot. Okay, notice it's Mary is 18 years older than Sarah. How do we translate that? Brianna? X equals Y plus 18. Perfect. Now, here's the harder part. Whoops. Okay, here's the harder one. 5 years ago, which terms am I going to use? The first column or the second column? Jessica, what do you think?
Well, the second column. But I did. Should I just say?
Yeah.
X minus 5.
Stop. X minus 5, that's Mary. What do I put for was?
I did plus.
Was. Is, was, will be is the same thing.
Equals.
Good. Twice as old as Sarah. Twice as old as Sarah. Is, was, will be is our equal sign. Shh. Be careful here. Daniel.
I think it's minus 5 equals 2x.
All I want is twice as old as Sarah.
Oh, 2y, sorry.
5 years ago, that means the whole sentence. It's 5 years ago. Not a piece of it, not just Mary. Olivia, what do you think?
Is it 2 times y minus 5?
Is this correct?
Oh, it's correct.
Do you distribute?
With 2 times the quantity of y minus 5. Right. So because they said this, Daniel, right here, 5 years ago, that means for everything in that sentence. Does that make sense? It's not just Mary 5 years ago. 5 years ago, Mary was twice as old as Sarah. That's the whole sentence was 5 years ago. Okay, yes.
If 5 years ago she was twice as old as Sarah, wouldn't that mean she's still twice as old as Sarah?
Not necessarily.
No, if you're like 5 and she's 10.
Okay, let's look at this and then we'll compare that. So now, what am I doing? Substitute for the x. Okay, you guys finish it up. I'm going to erase this and just use the PowerPoint because it's neater. So now what am I doing? You said substitute. I'm substituting in. And now we have to simplify. Once I've eliminated one variable, we're left with y plus 13 equals 2y minus 10. I'm going to subtract y from both sides, add 10 to both sides, and y is 23. How many people got that answer? Yes. Okay, give yourself a pat on the back. You didn't? What did you do wrong?
I multiplied it like 5
5 and y. Where did you multiply?
Yeah.
Oh, well, this is really a 1 here that's right next to it. So unless it was like the 5 is touching this side, or the 5 is actually touching the parenthesis on that side. Okay. So now, if she's 23, how old is Mary? Nora?
Oh, can I go fix my
Yeah. If she's 23, how old is Mary? Anybody? Yes.
She is 41.
So I add my 23, 18, and it is 41. So now, is this twice as old, Claire? Well, who asked that question? Okay, Claire, is that twice as old now?
No.
No. But if you put it in here, it will work out. Maybe 5 years ago it was a true statement, but not here. Okay? Questions? So, now, Sarah now is 23 and Mary now is 41. Make sure you make sense of that X and Y. Don't just give me an X and a Y in an answer column. Yes, I don't see whose face that is. Oh, okay, Cassandra.
You minus the y, but we used it for the next step.
What'd you say?
You minus the y on both sides, but you used it for the next step.
I don't understand what she's saying.
Oh yeah, I see that.
Okay, this is like a mixture problem, an easy mixture problem. Eventually, we're going to start talking about fat and percents and acids and non-acid solutions or mixing acids. Shh. Okay, but right now we're talking about items. Now this time I'm going to use my box method to solve it. And you may as well make 9 boxes, 3 on 3. 3 rows of 3. I don't always use all 3 rows, but I always make it like this because I don't know if I'm going to need them. What are we comparing? Raising a quiet hand. Anybody? Come on, somebody's got to have a guess. Read the problem and tell me what we're comparing. Daniel, what are they? Specifics. What am I writing on my left?
The
Calculators and notebooks. So I'm going to add my calculators and notebooks. Okay? Now, don't worry about it. We'll get to it. That third row? Okay, you can't be using that. You got to sketch it because you got to do it fast. You're not going to have time to make perfect boxes. Okay. Now, when I'm comparing I'm also comparing, notice right here, it says Joe bought 15 items for $135. We are comparing quantity and dollars. So, if they give me a quantity and a dollar amount, that's usually the easiest kind of problem because I can always set it up like this. The first column I'm going to name amount or quantity. The second column is unit value. And what units are we talking about? So we said amount is one of them. And what did I say? What's the unit value of each item? What does that mean? What's the unit value for a notebook? Yes. One cost. The money. It's the money. For one. For one. Per one. Okay? Now, I'm not comparing units. I'm not comparing like milliliters or cups. I'm comparing dollars. Now, we multiply going across and we get a product. We add going up and down and we get a total or a sum. Remember I said we're going to do 3? Okay, so now I'm going to start adding what I know. What do we know for sure? The easiest piece. Do we know the unit value of a notebook? How much is it? $4.50. Do I know the unit value of a calculator? 12. Do we know how many notebooks we have?
No.
So guess what? I'm going to call it. Do we know how many calculators?
No.
Now notice this is not a dependent-independent relationship. I'm assigning variables for unknowns. Oh, shoot. Yeah, I did. Okay, I thought I stopped. So I'm assigning the variables for the unknowns. Now, I said, what do we do going across? What? Multiply. So 4 5/10 times x is 4 5/10 x. What's the next one going to be? 12y. Multiply across. I'm multiplying across. Now, there's one more. I've used this. I've used this. There's 2 more pieces. I have 15 items. Is that go in the number column or the total value? That's an amount. That's a quantity. So that goes, it's a total quantity. It's not the quantity of one or the other. And the 135, that's a total cost. So that's going to go right here. My total cost. So now my equations are x. No, we've already multiplied across. Remember I said across we multiply, up and down we add. And what we have here are our two equations. X plus y, oops. I have x plus y equals 15. And what's the other equation? Okay, now, you guys good with that? Okay, I'm going to erase this and put it in PowerPoint. Is that okay? Jamie, are you okay that I erase this and put it in PowerPoint? Okay, so, I'm going to do... All right, so I leave that extra box in the center and I don't fill it in because just in case, whatever, I need it. Later on, we'll need it. Right now, we don't need it. Now, we said these are our equations. What's the easiest way to solve this? Nora? Elimination. Why? They're in standard form. So now I'm going to, what do I need to do to eliminate? Yes.
You need to change the first equation and make it so it's the opposite.
Right, and the easiest one I think, actually I would probably, 12. So what am I going to multiply everything by? Good. And then we get negative 12x minus 12y equals negative 180. I don't personally subscribe to this double sign stuff. I would get rid of that and just make it a negative. And then I'm going to 4 and 5/10 x, line it up, and we're going to add going up and down. So here, am I adding or subtracting when I do negative 12 and 4 and 5/10 x? Really subtracting. So 12 minus 4 is 8, minus another half is 7.5. These eliminate, and I'm left with negative 45. Divide both sides by negative 7 and 5/10, and x is equal to 6. Okay, so I substitute my 6 in here. And then, can we figure out how many calculators we have? What am I doing? Substituting for the, I think, x plus y. So 6 plus what equals 15? 9, and I'm plugging that in there. Now, and take it back to the story. How many of each did he buy? 6 notebooks, 9 calculators. Okay, so 6 notebooks and 9 calculators. You always want to take it back to the story. Questions? Last one for the day. Okay, what am I comparing here? What are we comparing? What do I write here? Brian,
So it's gonna be
just right here. Brownies, what'd you say? Cookies and brownies. Okay, what goes up top here?
It's gonna be
Somebody else. Somebody else. What goes in the top of the first column? Is that a hand up I see? David, what goes in the first column? Well, we'll use it as a hand. What?
Wait, in the box or
On top. Just the label for the top of the box. Somebody. How about Isabella? Go back to the last problem. What did I label it? Yeah.
number?
The number or amount. Look at your last set of notes, guys. So we're going to call this amount. This is going to be my my unit value. What am I talking about? We're talking about money. I use just write amount times money equals a product. Okay, now let's start filling in our boxes. Tomer, what can I place?
Cookie
Uh-huh.
equals X.
What?
Cookies equals X.
So he wants to call cookies X. What else can we place? Ari? Good. Do we know what do I put in the unit value for the cookies? Elisa? Be careful. Make sure you're showing 50 cents. And what is going to go the unit value? Olivia?
75 cents.
That's 75 hundredths. Now, what goes in the books for across, right here for total value? 0 and 5/10 X. And then what goes in over here? Elisa?
0.75 Y.
Now, I have two more items. What do I put in this box right here? Jordan? 40. Selling 40 baked items. Good. That's 40. What goes in this box right here? Someone I haven't heard from. Nicole. $24. Good. The total money. Total money. This is my total column. And we also call it a sum. And this is also my product. This is amount times the money equals amount times money. Product. Now, what are my equations? What are my equations? Jessica, give me one. X plus Y equals 40. And what's the other one? Carly?
0.5 X plus 0.75 Y is
Good. There you go. Now, this is when I really get into clearing. It's going to be the same thing, it's just in PowerPoint. Sometimes this is when I clear because I don't like to deal, but, with decimals. So now, what would be the easiest thing to do? I think I would want to clear because there's nothing easy. I think I would clear or use substitution. How about if we do substitution on this? What do you want to do? Well, okay. Huh? Wait, what?
We multiply by 0.75 on the top.
Yeah, or we could,
Point 5.
oh, you know what? Look at what my PowerPoint does. They're going to clear, and they're going to multiply the bottom one by
0.
-2. -2 times 50 cents. 2 times 50 cents is what? But -2 times 50 cents, negative X. 2 times 75 cents is $1.50 minus 150y. And then they cleared and gave us something.
Is that easier?
It doesn't matter. There's 10 different ways you could have done it. I could have cleared the bottom equation first and then substituted. I could have cleared the bottom equation and then multiplied the top one by 5. Okay? I could have done a lot of different things. So now we've got... Now, be very careful. If you get a negative, you got to have a negative on the other side because you can't have a negative dollar amount. So now I might even clear at this point. Multiply everything by 10, then I get negative 50y equals negative 80. If I don't want to deal with the decimal. Divide both sides by negative 5/10, and we get y equals 16. Now, what would be my x? What is my x? Yes.
Can't you subtract 40 by 16?
Yep. 40 minus 16 is 30 minus 6 is 24. So, we sold 24 cookies and 16 brownies. Yes, Daniel.
How is negative